Hi, my name is Uzair Khan and I work for the ASR9000 Scale and Performance team. And today I'll be presenting the new ASR9000 line card. It's a 16-port 10 gig line card which uses SFP plus optic connectors. We'll also be doing a brief demo today. The demo will be showing the forwarding capacity of this line card. We will be pushing 160 gigs of unicast plus multicast traffic across this line card. I'll briefly go over the topology and the streams that will be used for this demo. We have two 8-port 10 gig line cards driving traffic across the 16-port 10 gig card. The first stream that's coming in is a live multicast video feed that's coming in through a 7600 router that's acting as a switch. The video traffic is forwarded to the 16-port 10 gig card, and from there it's forwarded out to the set-top box and onto the LCD display. So the video stream that you are seeing here is coming through this 16-port 10 gig line card. The second stream that we are going to use for this demo is the multicast stream. 6 gigs of multicast traffic is sent across. It's replicated, and each of the receiving port is getting 6 gigs of multicast traffic. The third traffic stream is unicast data traffic. 4 gigs of unicast traffic is sent across the system. So each port on the 16-port 10 gig line card is receiving 6 gigs of unicast, 6 gigs of multicast, plus 4 gigs of unicast traffic, a total of 10 gigs. Now we'll move on to, before we move on to the live demo, just wanted to show the graphical representation of the data streams. We are receiving total of 160 gigs of traffic. Each port has 10 gigs of traffic. That's 6 gigs of multicast plus 4 gigs of unicast. And the bars here are showing 16 traffic streams, each at 10 gigs. And now I'll move on to the demo version. We will be seeing the unit under test, and I'll be going and displaying, shutting down some links, doing RSP switchover, and we'll be seeing that there's no effect on traffic. So if you look at this screen here, I'll briefly do a show platform. This DUT has 2 RSPs. RSP1 here is the current active one. RSP0 is the standby. Line card 7 is the new 16-port 10 gig line card. Line card 0 and 1 are the 8-port 10 gig cards. Now what I'm going to do here, just to prove that real traffic is flowing through this line card, I'm going to shut down one of the ports through which video traffic is flowing. As soon as I shut down that port, video streams would stop. Similarly, I'll also shut down one of the ports where data traffic is flowing, and as soon as I do a shutdown, one of the streams here would be lost. Here I am first shutting down the video link. As soon as I hit commit, video traffic stops. I'll do a no shut, and video traffic resumes. I'll demonstrate similarly for the data traffic. I'll shut down the port, hitting commit, and one of the traffic flows will stop. That's the first port here that went from 10 gigs down to 0. In the graph you can see in the middle, that stream, the throughput went down to 0. I'll do a no shut, commit, and you see 10 gigs is back up and running. Next part of the demo, I'll do a RSP switchover. The purpose of the switchover is to show you that there will be 0 packet loss for both the video traffic and the data traffic. I'll first quickly check that the standby RSP is up and running. It's ready. I'll issue the command. And here, I initiated the switchover. As soon as I hit the switchover button, you see no stoppage in the video stream, and there was no stoppage in the data streams. We are still receiving 160 gigs of total traffic with 10 gigs of traffic per port. This part of the demo deals with the advanced QoS capabilities of the ASR9000 and the 16-port 10 gig line card. So as you can see here, we will be stressing the line card by sending in 320 gigs of traffic, aggregate traffic. And while the line card is stressed, the video traffic will be flowing through the system because all the video traffic is marked as high priority. So we are going to show or demonstrate Fabric QoS, which will be protecting the high priority video traffic while the line card is congested. What I'm going to do here is remove the QoS policy, and as soon as I remove the QoS policy, the video stream here would become non-protected. As soon as that happens, the stream here will either stand or will stall or will become jittery. As soon as I reapply the policy, the traffic will be protected and we'll see the stream flowing through. If you follow me to the screen, I'll join the interface that is serving the video traffic. I remove the policy map here and I hit commit. As soon as I hit commit, traffic stops. I reapply the policy, hit commit, and the traffic starts to flow again. So now we have demonstrated Fabric QoS, and under congestion, higher priority video traffic can be protected.